Dear students, today in electrostatics we are going to study a very important and interesting topic, that is electric field lines or electric lines of forces. In this topic we are going to study electric lines of force due to a point charge, due to a dipole, due to like pair of charges having equal magnitude, due to a uniform field, and thereafter properties of electric lines of force. What is electric lines of force? An electric lines of force is an imaginary straight or curved path along which a unit positive charge is supposed to move when free to do so in an electric field. Electric lines of force do not physically exist, but they represent real situations. Here, all are the examples of electric field lines. That means they can be straight and they can be curved also. Now we are studying electric lines of force due to a point charge. If I am taking a positive charge, then I will be getting such kind of electric field lines, and if I am having a negative charge, then all the field lines will be approaching towards it. Okay, and you can see here the difference between the sizes. The sizes are representing the strength of the electric field. Near the charge, the electric field is more, and farther we are going, the electric field becomes lesser and lesser. Okay, if simply we have to represent, then we can do like this. For positive charges like this, and for negative charges like this. That means for positive charges they will be going out, and for negative charges they will be coming in. The arrows are very important here. Electric field line due to a pair of equal and unlike charges, which is called as dipole, which we are going to study later on. Here we find that the field lines are closer here and closer between the charges, and farther we are going from the charges, and the field lines are separated and scattered. And if we have to determine the electric field, the direction of electric field, then we have to take the tangent of electric field lines, and we will be getting the direction of the electric field. Electric lines of force contract lengthwise to represent attraction between the two unlike charges. Electric lines of force due to a pair of equal and like charges. If they are like charges, then we will be finding a neutral region over here in between the two charges, and electric lines of force exert lateral pressure to represent repulsion between the two like charges. Electric lines of force due to a uniform field, that will be a stator one, like this only, from positive to negative, from positive to negative, from positive to negative. And properties of electric lines of force or field lines, these are important ones, and you should be learning them. Number 1, the electric lines of force are imaginary lines. Number 2, a unit positive charge placed in the electric field tends to follow a path along the field line if it is free to do so. If we are taking a unit positive test charge or charge, then whatever path it will be following, it will be showing the electric field lines. The electric lines of force emanate from a positive charge and terminate on a negative charge. As was visible earlier, the electric field lines always start from the positive charge and terminate on the negative charge. The tangent of an electric field line at any point gives the direction of the electric field at this point. As done earlier, the tangent of any curved electric field line will be giving the direction of the electric field, a curved line or straight line. Two electric lines of forces can never cross each other. It is a very important point, and it comes in exams too. Two electric field lines of force can never cross each other. If they do so, then at the point of intersection there will be two tangents, which means there are two values of electric field at this point, which is not possible. And further we can say with the help of vectors, electric field being a vector quantity, there can be only one resultant field at the given point, represented by one tangent at the given point for the given line of force, as visible here. You can understand here. The electric field lines are having two directions. That means this is the electric field of this field, and electric field lines are having separate two electric fields E1 and E2, and if resultant is taken, then that is different. Okay, they should be same. E1 and E2 are same, then only they will be same. It is not possible. Electric lines of force are closer where the electric field is stronger, and the lines spread out where the electric field is weaker. Here the charge Q, capital Q, is having more value, hence the crowded part of electric field lines are shown, and Q is much smaller, having much smaller magnitude, small Q is having much smaller magnitude, so they are, the electric field lines are not that much crowded. Electric lines of force are perpendicular to the surface of positively or negatively charged body. Always and always they will be perpendicular. Electric lines of force will contact lengthwise to represent attraction between the two like charges. Electric field lines exert sideways pressure to represent repulsion between the two like charges. The number of lines per unit cross-sectional area perpendicular to the field lines is directly proportional to the magnitude of the intensity of electric field in that region. More crowding, more will be the electric field. Electric lines of force do not pass through a conductor, hence the interior of the conductor is free from the influence of electric field. In between a conductor there will be no field. This is called an electrostatic shielding tool. Then the last one, electric field lines can pass through an insulator. That's all for the topic. Thank you. Have a nice day.